Okay. So avalanche effect means whenever there is a particular change, then it will just affect the output drastically. Okay. So up till now we just consider the uh, hash. What is the hashing? Then which are the types of the hashing? That is static hashing and dynamic hashing. And inside that particular static hashing and dynamic hashing, we can use the hash table to store the particular values. Then hash functions which can be just applied on the particular keys so that we can able to find the direct location inside the hash table. Okay, so these hash functions again categorize into the four types, that is uh, division method, then multiplication method, then mid square method, and last one, that is uh, which is called as folding method. That is, we can able to fold the particular data or content. Okay. So inside that, again, we can use the sugar hash. So see, sugar hash having the particular avalanche effect, that is change in the one bit of the input affects the output drastically. Okay. So inside that particular, again, SHA is used for just uh, providing the security for the data. So inside the digital signature, we can able to use the SH algorithm. So now next, whenever we want to handle the collision. So collision means what? Whenever the hash function okay, so when the hash function maps two different keys to the same location. Suppose I am having the key that is 0, 0, 0 and 0, 0, 0. So these two keys that are just point out to the location 0. Okay. So in that particular case, collision is occurred or overflow condition is occurred. Okay. So to avoid that particular condition, we can able to resolve that particular collision by using overflow handling technique or collision resolution technique. Okay, so these are the two technique, one technique which is used to handle the overflow handling or collision resolution. So whenever we consider these two collision detection or collision handling techniques, then there are two possible methods for handling the collisions. So one is the open addressing and second one, that is chaining. Okay, so open addressing is also called as close hashing and chaining is also called as open hashing or close addressing. Okay, so here let's see one by one the open addressing technique, that is which is also called as close hashing. So open addressing or close hashing. Close hashing. Okay, so here inside this we compute the new positions using a probe sequence. And we can able to have either value, that is sentinel value, that is -1 whenever there is no value, and data value. So if we can able to find the memory location and check the value, if it is sentinel value, replace with our data value. Okay, so if it contains a sentinel value, then the location is free and the data is stored in it. However, if location is already having some data value, then other cells are examined in the forward direction. Okay, so this is the first rule and this is the second rule. Okay, so first rule is this one. This one. Okay, so if value is centimal value, that is -1 is available, then it will just indicate that location is free. You can directly store the value. If the location is already having the value, then search for the next or other slot and just find the next free slot which is available. And if free location is not found, then the overflow condition is occurred. Okay, so this is so the process of examining the memory locations inside the hash table is called as probing. Okay, so whenever we consider the open addressing, then it is having the four methods, that is linear probing, then quadratic probing, then double hashing, and fourth one, that is rehashing. So these are the four techniques which are under the open addressing techniques. So let's see one by one. So now inside the linear probing, we have to use this particular formula to calculate the hash function. Okay, so what is this particular formula? H of ki is equal to h of k plus I mod m. Okay, so k means your key value, k is equal to key, then so I means it is a probe number. So whatever the iteration of the probe, we can having that particular probe value. So it is just starting from 0 to m minus 1. And what is the value of m? M value you can just take based on the size of that particular table. So em is nothing but size of table. Okay, so these are the particular contents which are available. So k is the key value, I is the 0 to m minus 1, and m is equal to size of the table. Okay, so here I want to just allocate, or I want to just locate the particular elements one by one by using this. Okay, so let's see the example. So hash table of size 10. So value of em is equal to 10. Then insert the keys. So whatever the keys into the table. Okay, so our I is start with 0. So initial I is equal to 0. That is, we can just search the particular locations first time. Okay, so whenever we are not finding the location, we can increment the value of I to the 1. Good. So we just see the operation. So I just copy this particular and paste it in our example. Okay, so this is my example. Now I want to find the answer, that is storage of the each and every value inside the particular hash table. Okay, so this is the hash table. Hash table. So having the 10 size is equal to 10. So it is from 0 to 9. Okay, so our value of em is equal to 10. Value of I is equal to 0 initially, and k means key. Okay. So I want to just apply the particular formula which is called as, so key is the 72. So initially at first stage, I want to apply the formula, that is key is equal to 72. So 72 mod, what is the value of m? What is the value of m? That is 10 plus I upon mod m. Okay, so this is the particular formula. First of all, I just write the formula and then go forward. Okay, so hash function is equal to p mod m plus I mod m. So this is the particular formula which I want to use to calculate the hash function. Okay, that is the position. So initially I just consider this. So my key is 72 mod, value of m is 10 plus value of I is initially 0 mod 10. Okay, so this particular value is 2 plus 0 mod 10. So value is 2. Okay, so at the second location we can able to store this particular. Okay, so this 72 goes to the this particular location. So here I just store the 72. Got it? Then next I just consider this 27. So second one, that is key is the 27. So again I just use the same formula, 27 mod 10 plus 0 mod 10. Okay, so is equal to, I can get the value, that is 7. Okay, so at the 7th location I can store this particular 27. So here I just store the 27. Okay, then here I can get the another key, that is 37, 36. So 36, again I just calculate 36 mod 10 plus 0 mod 10. Okay, so the value is 6. Okay, then at the 6th location I can just store the 36. Okay, then again for fourth key I can consider the 24. So 24, so again 24 mod 10 plus 0 mod 10. So what will be the value? Value will be the 4. Okay, so at the fourth location I can just store the 24. Then again I can just store the 63. Okay, so 63. So here 63 mod 10 plus 0 mod 10. So value is 3. So here I can able to store the 63. Okay, then next 6, that is 81. Okay, so 81, again same formula, 81 mod 10 plus 0 upon 10. So value is 1. So I can just store the 81 in the first location. Okay, then next one, that is 97. So 92. So here we can get the value, that is 92 mod 10 plus 0 upon, that is modulus 10. So value is 2. Okay, but whenever you observe that the location 2 is already full. Okay. Okay. So not able to empty. Okay. Which is already have the data. So here, whatever the value we just consider as a 0, we have to just increment the next location by just incrementing the value of I to the 1. Okay, so initially I is equal to 0. Okay, so the value is not able to fit. So I can just increase the value. So 10 plus 1 mod 10. So what will be the value over here? So we can just have the value as 3.
3.
Okay. So here again, if you observe that particular 3 is again full. Okay. So again, we can just increment I is equal to 2. Okay. So again, we can calculate the value mod 10 plus 2 mod 10. Okay. So what will do the value? 2
4.
plus 4. Okay. 4. Okay. So again, whenever we just observe that this is also full. Okay. So again, in that particular case, I can increase the value of I to the 3. So 92 mod 10 plus 3 upon 10. So what will be the my value? 5.
5.
Okay. So now search whether the 5 is available. Yes, 5 is available. Okay. So here I can able to store the value 92. Okay. Again, we can just have the last number, that is 101. So 101 is equal to 101 upon 10 plus 0. Okay, so here we just start with again 0. Okay, so here mod 10. So what will be the value?
1.
1. Okay, so again it is found that 1 is already filled. Okay, so again we can just increment the value I is equal to 1. Okay, so for that again we just calculate the mod 10 plus 1 mod 10. So in that particular case, again value is 2. Okay, so again 2 is fulfilled. So we can increment up to the 8 location. That is, we can just check for this particular this, and for I is equal to 2, 3, 4, 5, 6, 7. For I is equal to 7, we can able to find this particular location. Okay, so up to I is equal to 7, we need to continue. Okay, and we need to just store that particular inside the 8 location for I is equal to 7. Okay, so here for I is equal to 3. Okay, so in this way, I can able to store the particular number inside that value. Okay, so this is called as linear probing. That is, we can be able to find the location, and initially the value of I is 0. Whenever we search the next location, which is fulfilled or which is full, then we can increment the counter of I by 1, and we can able to just search the another location up to whatever the location which we can able to found free. Okay, so these are the two locations, or these are the two values which we can able to require the probing. Okay, so this is called the mechanism of the probing, where we can able to increment the value and we can go for the different value of I, so that we can able to find the free slot inside the hash table. Okay, so this is called as linear probing. Any doubt related to this?
No, sir.
Okay. Then next one, which is called as quadratic probing. Okay, so quadratic probing, inside that inside the quadratic probing, what happened? We need to add the two constants inside this particular function calculations. Okay, so C of C1 and C2. So these are the two constant values, and again m is just changing from 1 to 0 to m minus 1, and value of I we can able to just calculate from 0 to m minus 1, and m is whatever the uh, particular size of that particular data, we can just calculate as a m. So m is a size, m is equal to size, I is equal to 0 to m minus 1, and c1 c2 constants, and k is equal to key. Okay, so this is the particular formula which is need to apply to calculate the hash function. So inside the quadratic probing, we need to add two more parameters, that is constant value, and we need to change the hash function formula. Okay, so let's see the example related to the quadratic probing. Okay, so same logic we can able to apply over here. I can just copy paste that particular content, and again okay, so this is the particular example. Again, we need to apply the formula. So which formula? That is h of k is equal to e plus c1 into I plus c2 into I square. Okay, mod m. Okay, so here m is equal to 10. Okay, so which is already given. So here size is equal to m. Then c1 is, where c1 value is 1, c2 is equal to 3, and whatever the key value we already know. Okay, so here we can calculate one by one what are the formulas or what will be the value over there. Okay, so first what we require for 72, I want to calculate the value. So 72 is equal to 72 plus what is the C1? 1 into I0 plus C2, that is 3, into I square, that is 0 square, mod 10. Okay, so this is a particular formula which I want to I need to apply over there. Okay, so here again, this is the key mod 10, that is M. Okay, so here I need to just apply the function. Okay, so HK function is there. So key mod M. Clearly, I just write out. Just 1 minute. Key mod M plus. Okay, so this is 1, this is 2, and this is 3, and mod M. So I need to just write 72 mod 10. So what will be the value? Is equal to 2. Okay, so whatever the into 0 means all the values get 0. Mod 2 means 2. So here I can able to store the 72 at this particular location. Now goes to the second, that is 21. So again 21 I can able to store inside the first location. So value is equal to 1. Okay, so here it is a not 21 and 27. Okay, so value is 7. So I can able to just store the value inside the this particular. Then again 36. The third is 36. So I can just able to calculate the value and store it inside the sixth. So I can able to just store 36 over here. Okay. Then fourth 24. Okay. So 24. So value that comes as 4. So I can be able to just store as a 24 over here. Okay. Then fifth, we can use the 63. So 63 value is 3. So we can able to store the number into the third location. Now here we require the calculations. Okay. So now number is 81. So here 81 by default value is equal to 1 for I is equal to 0. Okay. So 1 is already 1 is not full. So we can able to use the 81 over here. Okay. Then for 101, we require the probing, that is quadratic probing. So here 101 for I is equal to 0, what we require? The value is 1, so which is already full. Okay, so full. So full, so we just move towards the I is equal to 1. So again we calculate the value. So 72 mod 10 plus 1 into 1 plus 3 into 1 mod 10. So 2 plus 1 3, 3 plus 3 6. Okay, so value is 6. So again that particular, not 6.
The 72 101.
It's 5.
It's 5. Okay. So fifth location is available. So here we can able to store the 101. Okay. So 101 is stored inside the fifth location. So this is called as quadratic probing. Only formula get changed. Okay. So here what is the formula? H of k is equal to P mod M plus C1 into I plus C2 into I square mod M. Okay, so this is the particular formula which I want to use and I want to just calculate the particular values. Okay, so this is called as the particular hashing by using or overlapping or collision we can able to avoid by using the quadratic probing. So only change in the formula, whatever the other logic gets remains same. Okay, so only over here I can able to use the I is equal to 1. Okay, so this is called as quadratic probing. Then next operation related to the uh, hashing is nothing but what do we call it as a so these are the particular operations and all steps are given over here. Then next one, that is double hashing. So double hashing means what? Here use one hash value and then repeatedly step forward in the interval up to or until the empty location is such. And interval is decided using the second independent hash value, which is named as double hash. Okay, so here what happens? We just multiply the I by the particular C1, C2 or directly. Okay, so here in this particular case, we can able to multiply the probing iteration with the help of the another hash function. Okay, so this is the first function, this is the another function, and this is the I, and this is the M. Okay, so M is nothing but the size, I is nothing but the probing, and HK is the first hash function, and H1 and H2 K is the second hash function. Okay, so only change in the formula. So here somewhat different formula is available. We need to just adapt that particular formula and we need to perform the double hashing. Okay, so let's see the example related to the double hashing. So here I just take the screenshot of that so that it will just useful for us. Copy and paste it. Okay, so here I want to just perform the double hash. So what is my logic? Double hash. So here value of m is equal to 10. So that is given over here. Then hash function, first hash function formula is this one. That is k mod 10. And second for hash function formula is k mod 8. Okay. So initially we just probe that particular number, and whenever the empty space is not found, we can apply the second hash function. Okay, so here the formula get changed. So here h of k is equal to h1 mod m plus I into h2 mod 8. So here instead of h1 and h2 I just write k, because that particular formulas is available. So k mod m, that is 10, k mod 8, and whatever the modulus of all this particular, we can able to combine mod 10. Okay, so these are the particular formulas. So this is the H1, this is the H2, and this is the value of M. Okay, so this particular formula I want to use to calculate the H value. So let's see how we can able to work. So consider the first, that is 72. So 72. So I can just calculate that particular value. 72 mod 10 plus 0. 72 mod 8 mod 10. Okay, so what will be the value? That is 2. Okay, so simply we can able to get the value because here 0 is there. So whatever the into 0 is 0. So I can get the particular value, that is 72, which is stored over here. Similarly 27. So I can just have the 27. So value is again 7. So I can just store the 7 over here. Again 36. So 36. So value is 6. So I can able to store the value inside the sixth position. Again 24. So fourth one is 24. So value is 4. So I can able to store the particular data into the fourth. So here I can able to store the 24. Again 63. So for again 63, we can able to just store the particular data. 63. So value is 3. So I can able to store the 63 over here. Again 81. So 81. So I can able to store the value inside the 1. So here I can write 1. Again 92. Now for I is equal to 0, the value of 92 is 2. Okay. So this is the already full. So I can just increase the value by 1. Okay. So here I is equal to 1. I can able to consider the hash function. So here formula is 72, 92 mod 10 plus 1 92 mod 8 mod 10. Okay, so what will be the value over here? Yes, anybody? So whatever the value of this is 2, whatever the value of this is 4. So 2 plus 4, that is 6. Okay, so again 6 is already allocated. Okay, so it is again full. So this location is full, this location is full. Again, we can increase the value of I to the 2. Okay, so again 92 mod 10 plus 2, 92 mod 8 upon 10. So what will be the value? Here value is 2 plus here value is uh, 2 into whatever the 4, that is 8. So the location is 10. So 10 mod 10, that is 0. So our 0th position is available. So I can insert the 92 over here for I is equal to 2. Okay. Then last one, that is 101. So again, we can able to just get the particular value. So 101. So first for I is equal to 0, 1 is there. So 1 is already filled. Then I is equal to 1. The value which is coming, that is 6. Okay. So 6 is already filled. Again, we can move towards and we can able to prove that, and for m is equal to So we can able okay. So just tell me what is the location for which we can able to find the particular location free for 101. For 1, we can not able to find the value. Then for 2, whether we are able to find the value, just check it out. So in this way, we can able to just find the location and we can able to find empty slot by I is equal to 2, 3, 4, whatever the value. Okay, so in this way, we can able to just find the value uh, with the multiple probing. Okay, so here this is called as double hashing. So double hashing means what? We can have the two hash functions. Two hash functions. That's why it's called as double hashing. And that particular functions we can able to apply and we can able to perform the hashing. Okay, so you can solve this particular example so that you can able to get the particular specific concept in our program. Okay. Then next one, so clear up to this. That is only change in the particular. We can have the change inside the only hash function. So inside the linear probing, formula is different. Inside the quadratic probing, formula is different. Inside the double hashing, again formula differs. Then inside the rehashing, again we have to just another logic. Okay, so inside the rehashing, what happened? Inside the rehashing, when hash table becomes nearly full, the number of collisions increases and it will just degrade the particular performance by insertion and search operation again and again. Okay, so inside the rehashing, what happened? We can able to create a new hash table which size double the original hash table. Okay, so this is the particular logic which we can use inside the rehashing. Okay, so create a new hash table with size double the original size and all entries of the original hash table we have to move towards the new hash table. Okay, so this is the first logic which you want to apply and this is the second which I need to apply. So first create the size, double the size of that particular hash table and then reallocate the particular entries. So initially, whenever we are just using the hash function, that is hx is equal to 5, then this is the x key upon 5, that is mod 5, we can be able to get the particular number. Okay, so 26 mod is 1, for 31 mod is again 1, because of the linear probing we can just shift to the next location, then 43 and 70. Then inside that we can create the new hash table of 10 location, that is double the size. So initially we are having the 5, we can double. So here 10 locations are there. Now we need to reallocate that. So what do we do with the hash function? We can consider this particular hash function, that is x mod 10. So whatever the 31 is allocated at the first location, depending on this particular value, then 43 at the third, then 26 at the sixth location, and 17 is at the 7th location. So this is the particular logic which we can able to apply inside the particular. So hash function is whatever the x mod 10. Okay, so this is how we can able to rehash the particular content. So again, rehashing is not a good technique because we need to readjust the location which base the particular resources whichever required for the particular rehashing. So again, for that we need to just consider which is called as consider the another part which is called as the chaining techniques. Okay, so these are the 4 techniques which are under the open addressing technique. So first technique is linear probing, second quadratic probing, third double hashing, and fourth that is the rehashing. Okay, so these are the first part which are included. Again, inside that we have the second technique, that is chaining technique. So chaining technique is also called as open hashing, or we can also call it as a closed addressing or closed addressing. Okay, so these are the 3 names which we can able to alternatively use for the second. So here inside the hashing we can use the pointers. Okay, so pointers to the linked list that contains all the keys values hashed to that particular location. Okay, so suppose there are multiple keys, then we can able to use the pointers like this to just represent the locations. Okay, so this particular linear linked list concept we can able to use to point out the particular contents. Okay, so let's see the example related to this. So here again inside the chain hash table we can have the 9 memory locations. So here the value of m is given as 9. Okay, then value of k is this one. So we need to simply use the formula, that is this particular function, that is k mod m. So initially 7. So 7 is stored at the 7th location. Then 24. So 24 is just stored at the particular location, that is 6th location. Then okay, so here we can just use the mod operation. So the reminder is 6. So we just store at the 6th location. Okay, so 24 is attached to this. Again, we can just apply the. So here we are not applying the mod 10. We are applying the mod. Why? Because our memory locations inside the table are only 9. So value of m is equal to 9. So in previous example, value of m is 10. That's why we just mod 10. But in this particular example, we just consider the 9. So again, for this particular 18, we get the value that is 0. So we just store at the 0th location. For 52, we can get the value as 7. So we can again 7, but 7 having one element. So we can just add this particular element as a linked list. Okay, so pointer we just apply linked list pointer. We can just apply again 36. So for 36 we can just get 0. So we can add over here. Again for 54 we can again get the 0. So we can attach one more over here. Okay, So in this way, we can able to just add the particular contents. Again, for 54, we can get 2. For 11, we can get the 2. So we can just add this particular. Then for 23, we can get the 5. So we can able to add the 23 over here. Okay. So in this way, we can able to just attach the particular overlapping elements by just forming the chain. Okay. And we can just store the address of that particular element as a reference. So here address of 36 is stored. Here address of 54 is stored and so on. Okay. So last element is always X. That is null value. So this is null value. So in this way, we can able to just store the particular elements inside the program. Again, next one, that is which is called as, so this is the first technique, that is chain hash table. Then next one, so only two techniques are there, that is close hashing and open hashing. Okay, so inside the close hashing, we are having this particular, and this is the difference between the open hashing and close hashing. Okay, so whatever we just previously seen, this is the close hashing. So it is also called as open addressing, where we can able to store the data directly and linked list is not used. Again, index keys are actually stored and may depending on the key value, and it is for small number of records over here. And inside the open hashing, that is our last discuss. We use it is also called as close hashing, stored in the linked list fashion. Then we can able to maintain the links with the help of linked list, and for the large number we can able to use the records. So these are the two techniques which are available inside the static hashing. Okay, so to locate the particular data, we use the hashing with the help of the hash function. So we are having the two types, that is open hashing and close hashing. So we just see that particular types. So inside the close hashing, we are having the again 4 different types. That is linear, quadratic, double, and rehashing. And in open hashing, only one type, that is chaining. So we can just discuss that particular chaining. Okay. The next part, that is dynamic hashing. So dynamic hashing means what? It is a hashing where the data that can be just inserted based on the particular data size. Okay, so inside the static hashing, if data we are not able to expand the data dynamically, then whatever the size of data or whatever the empty spaces that are growing. Okay, so dynamic hashing is a flexible enough to allow the data buckets to add and remove dynamically as per the requirement or as per the demand. Okay, so dynamic hashing having again two types. First one, dynamic hashing with directories and dynamic hashing without the directories. So these are the two types which are used inside the dynamic hashing. Okay, so let's see dynamic hashing with using directories. Okay, so inside that particular hashing using directories, first understand the problem. Okay, so here suppose I want to just allocate this particular number. Okay, so numbers are represented by the 2 bits 0, 0, 0, 1, 1, 0 and 1, 1. And depending on the number, I can able to store the data in the specific location. Suppose if number collision is occurred, we can increase instead of the 2 bit, I can increase by 1, that is 3 bit. If collision is occurred, I can increase by the 1, that is 4 bit. And so on. Okay, so in this way, inside the dynamic hashing, I can able to increase the value and adjust the values based on the requirement and recompute the hash function. So whenever the size get double, we can again recompute the particular contents. Okay, so here initially 4 locations are there. With the help of new, I can able to just relocate and add the new locations inside the directories and reallocate the particular contents again. Okay, so add the bit. So this is the first step. Add the bit in the value, and depending on the bit value, we in the hash table we can grow the size accordingly and recompute the hash. Okay, so these are the only 2 steps which are required inside the dynamic hashing with directories. Okay, so let's see the example how we can able to perform these particular operations. Okay, so initially we can just have this particular example. So let's see the example clearly so that you can get the detailed references related to it. Okay, so this is the particular example which I want to just add. So I want to just insert these particular keys in my program. Okay, so this is the particular keys which I want to just insert. So which those keys, that is, I have this particular A0, A1, B0, B1, C2, C3. Okay, so depending on the last digit, I can able to just assign the values. Okay, so here initially I can able to just add these particular values in the particular table. So I can having the directory. Okay, so here I can have the directory having 00, 01, 10 and 1. So these are the 2-bit digit number, and you can just point out to this particular. So 00 is appeared inside the A0 and B0. So I can able to point out the A0, B0. Then 01 is appeared inside the A1 and B1. So I can have the particular A1 and B1. Okay, so just observe the last 2 digits. 10 is appeared inside the C2. So I can just able to point at C2. Okay, then 11 is appeared over here, that is C3. So I can able to just point out over here, that is C3. Okay, so these are the particular contents which I have added. Now, suppose I want to add the number. So what is my number? C5 is equal to 110101. Okay. So just observe the last 2 digits, that is 01. So 01 already locations are full. Okay. So instead of the 2-bit system, I can increase that particular into the 3-bit. Okay. So what are the combinations inside the 3-bit? I can have the combinations like this. So 00001 001 10 11 again 00011011. So 001111. Okay, so these are the particular 8 directories which I have created. 1 2 3 4 5 6 7 and 8. Okay, so now whatever the contents which I have, I want to just reallocate the particular whole, rehashing the whole numbers. So again, I consider the three digits. So here I can able to add the A0, then 001. So here I can add A1, then 000. So B0 I can just add over here. Then 001. So again I just add B1. Then 010. So 010 here I just add C2 and 011. So 011 here I just add C3. Now just check, my number is 101. Okay, so I can just search for 101. So here I can just add the C5. Okay, so 010. Here I can able to add this particular C5 inside my program. Okay, so in this way I can able to just point out the particular number. Now suppose again I need to insert one more number. For example, C1 is equal to 110001. Okay, so now I just consider 001. So this particular 001 again get full. Okay, so here I can increase the 3-bit size to the 4-bit. Okay, and I want to again draw the particular numbers. So I can just draw that particular series. So 0001 1000, then 0001 1011. Okay, so here 11 is appeared. Again 0001 1011, 0001 1011. So here again 0000 1111, 0000 and 1111. And here 4 digit is 0 for 8 digit and 1 for next digits. Okay, so in this way I can able to just add that particular content, and here I can just form the particular numbering over here. And so inside the book it is given complicated, but I just simplify this particular. Okay, so I can just revise this with ease so that you can able to handle that. Now I want to again rehash by using the 4 digits. So 000 having the which number? A0. Then 0001 having the particular number, that is A1. Okay. Then next one, that is I want to consider the 1001. So 1001 is appeared where it is appeared. 1, 2, 3, 4, 5, 6, 7, 8, 9. 100 is appeared over here. So my B0 position get changed. Okay, so 0, I can just write the B0 over here. Okay, then next one, that is I just having the B1. So 1001. So 1001, that is I just appeared B1 over here. Now C2, so 0010. 0010, so the C2 is appeared over here. Okay, then 0010. So 0010. So C3 is appeared over here. Then my next number, that is, consider this whole number, that is 0101. So 0101. So my C5 is appeared over here. And my new number, that is 0001. So it will just appear over here. C1. Okay. So this particular calculations we can able to just perform and rehash the particular contents again, so that we can able to consider the particular bits. Okay. So inside this, we can just consider this 2 bits, inside 3 bits, and here 4 bits. Okay. So for whole this particular, we can able to rehash and again adjust the particular contents accordingly. Okay, so this particular things, it has been given. So in the book, whenever you observe the book, so book doesn't contain the such details, so they are giving this particular directly. So this again, this particular calculation is useless. Again, these particular lines are not expected. Again here, again this whole calculation doesn't understand. We finally get the this particular calculation. Okay, so whatever the calculations which are written over here and whatever we got, same calculations are there. Okay, so again all things that are explained. So again in that particular example, again we are not able to get the A0 over here. So A0 is available over here. Okay, and again one more number is inserted, that is C4. So C4 we can able to insert. Okay, so C4 is equal to, what is the calculations? 1010100. So just consider the last four, 0100, 0100. So here I can able to insert the C4. Okay, so in this way, I can able to calculate each and everything inside this particular example. Okay, so if you are not attending the lectures, you didn't get these particular concepts. So these are the particular concepts which are very much tougher whenever we are just able to read the particular content. So thorough understanding is required to reading the contents. So I am just explaining this particular content in the simpler way so that you can able to get the particular details related to it. Okay, so initially we consider 2, again we can consider the 3, and again we can consider the fourth one. Okay, so in this way I can able to just get the details related to the contents. Okay, so have you clear related to this?
So,
Yes.
C4, C5, we have to calculate.
No, C4 means what? We consider the last 4 bits. That is, these numbers I want to insert.
Okay.
Okay. So what is the logic?
Problem,
Initial.
they will give C4, C5, right?
No. What is the logic? Initially, we are having this key. Okay.
Oh.
So these particular keys which are fit inside the 2-bit system. Now I want to insert this particular C5. So whenever I want to insert this particular C5, in that particular case, what happened? C5, where it is going? Yes. For C5, our
101.
digits are this one, that is 01. But 01 having already two numbers are already stored. So it is full. So we can
No, sir,
convert this.
I understand that.
हा
पण सर ते C5 C4 हे आपल्याला दिलेलं असणार ना क्वेश्चन मध्ये.
हा बरोबर आहे, दिलेलं असणार.
हा तेच विचारायचं.
Depending
ओके,
upon
बाकी
that only you can able to just extend the system from 2-bit to 3-bit, 3-bit to 4-bit.
ओके 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 अंडरस्टँड.
येस. आता 3-bit ची 4-bit मध्ये कशी झाली, कारण 001 ला आपल्याला इथं फुल आहे,
फुल होतं त्या.
म्हणून आपण परत 4-bit मध्ये कन्वर्ट केलं आणि परत
ओके
इन्सर्ट केलं. Okay, so in
ओके
this way we can able to just add the particular content inside the dynamic hashing with directory. Okay, so any other doubt? No. Okay, then we can move towards the last part. So inside the book this will be missing, that is A0 is not, they have not counted A0. So this is the mistake that can be just appeared in the inside the book. So I have just entered that particular number. Then directory-less hashing. So directory-less hashing means what? Here the directory-less technique uses one of the traditional rehash function, just like open hash addressing, and its aim is to avoid the use of directories whatever the way in which we can just use. Okay, so instead of the hashing again and again, and we can increase the particular bit system and rehashing, we can use the directory-less system. Okay, so here this we can use the rehashing function and we can just apply the probing. Okay, so inside this particular, again, what are the rules? Here the main steps inside this particular techniques are: use the hash function to calculate the addresses. The hash functions are used. Then split the bucket whenever it overflow. So we need to split the particular buckets. Buckets always split in the linear order. So whatever the splitting, that can be just, so 4, that can be just splitting into the 8 and so on. Okay. Then buckets are split in round from top level to the bottom level. Okay, so round begin at the bottom bucket that has been split. Next bucket split when some condition is met, and any bucket can overflow pitch. Okay, so let's see the example how we can able to just do this. So if we have the record, that is A0 B0 stored in the pages 00, so A0 B0 we are just storing. Then C2 is stored in the 01. So C2 is also stored in the 01. Again, B1 is stored inside the page 10. So B1 is stored inside the 10. And C3 is stored inside the 11. So C3 is also stored inside the 11. Then again, A1 is stored inside the 10. So A1 is also stored inside the 10. Okay, so A1 and B1 that are also stored inside the 10. So this is our initial. Okay, so initial conditions are there which are already stored. Now, whenever we are having the trying to enter the record C5 inside the 01. Okay, so C5 I want to just inside enter inside the 01. So here I think the book having the problem. Okay, so here C5 we need to install inside insert inside the 10. So here it is given. Insert C5 page 10. Okay, so here I want to just try to insert the C5. So overflow is occurred. Okay, so that particular overflow we can able to resolve by just splitting the particular page 00 into the 100. Okay, so here we need to just add the particular contents depending on the requirement. Okay, so let's see the example and then only you can able to understand that. Okay, so here inside this particular example, what happened exactly? I will just paste this particular whole thing. Okay, so this is the particular example. Now, here what happened? Whenever I want to insert this particular C5 in the same, that is 10, then overflow is occurred. So for that purpose, I need to insert one overflow page. Okay, so I need to insert one particular overflow page. So I just add 100. Okay, so in previous example, what we are doing? We are adding here what we are doing? We are adding the 4 different pages. Okay, starting with 100, 101, 110, and 111. Okay, so instead of adding the 4 different pages, that is, we are just shifting the bit from 2 bit to 3 bit. We are just only add the single page, which is also called as overlapping page. Okay, so that particular page I have inserted over here and just link that particular to the same location. Okay, so this is the only difference. Then again, suppose C1 is added inside the same page. Okay, so C5 is already added with one particular page. So this particular page is happen over here. Again, the another page we have, that is the particular 00. So here the C1 is added in the page 10, again overflow is occurred. So we can just split the page 01. Okay, so new pages get added and we can just attach the reference over here. Okay, so in this way, we need to just only add the pages inside the same dynamic hatching. Okay, so here the logic remains same. Only we need to add the pages and we need to just link the specific content by using the linked list. Okay, so only this much change that can be just occurred inside the dynamic hashing without directories. So in the without directory, we need to add the new pages, which is also called as overflow pages. And we need to add the link for that particular overflow page inside the same block. Okay, so in this way, from 2-bit system, we can just shift, but part-wise, we can just shift that particular system. So we are not adding the particular content multiple times. We only shift the or add the contents one by one. Okay, so here I just add the first page for C5. Then this is the particular page for T1. That's it. Okay, and I can just currently link that particular, and I can only use the contents from the same page. So instead of adding the four different double the particular bit, I can only add the pages whichever required. That's it. So only this much logic that can be just available inside the um, directory-less hashing, directory-less dynamic hashing. Okay, so all this particular part we can have inside our book, and we can able to use the different applications related to the hashing. So that particular applications include databases, again the driving license or insurance cards searching or sparse metrics. So these are the particular applications where we can again use then file signatures, game boards, graphics, and so on. So in all these particular applications, we can able to use the hashing concepts again and again. Okay, so this much very small and very uh, easy chapter whenever we are just understanding the particular concept. Okay, so only we need to understand the hash function, and we need to just allocate the elements within that particular hash function. Okay, so any doubt related to this?
No, sir.
Okay,